everybody, welcome to my video. In this video I'm going to show you how to convert empirical formula of a compound into its molecular formula. Let's remind what's the meaning of empirical formula. Empirical formula is the simplest formula for a compound. Molecular formula is the original formula of a compound, and there are two mathematical expressions, mathematical formulas to be known to find the molecular formula of a compound, and they are n times empirical formula mass is equal to molecular formula mass. Another one is the n times empirical formula is equal to molecular formula. Okay, there are some different concepts here. Let me explain them. I'm going to make them clear for you. Empirical formula mass is the mass of a single molecule of empirical formula. It's going to be in unit of AMU, and molecular formula mass is the mass of a single molecule of the molecular formula, yeah, and it's going to be in unit of AMU. For these questions, we must analyze the questions carefully. What are the givens, and what are the known facts, and what is the unknown must be separated and must be known clearly. Okay, I have two questions in this video, but the second question is the most difficult kind of the question. I think there is no more difficult question than this question. For this reason, second question is really very important. Okay, let's start with the question one. Let's read it. Determine the molecular formula of the compound with an empirical formula OCH. Okay, here we have a given. The empirical formula of a compound is given. It is CH. Okay, we write it CH is the empirical formula, and a formula mass of 78.110 AMU, and also there are average atomic masses of the elements given in the question, as you see. This formula mass is known as the molecular formula mass. So I have the molecular formula mass. As I told you, I have two mathematical formulas. We're going to try to find each givens or each concepts. After finding them, we will put them into our formulas. Then we will get the result, which is called as the molecular formula. Okay, I have a formula mass given in the question, so it is molecular formula mass. I write directly 78.110 AMU. Okay, and n times empirical formula mass is equal to molecular formula mass. Here, to find the n, I need to find the empirical formula mass. Empirical formula mass, I can find it via empirical formula given in the question. It is CH. And also, average atomic masses are given at the end of the question. I have one hydrogen atom in the compound, as you see. In my empirical formula, I have one hydrogen atom. And one hydrogen atom makes 1.01 AMU. Hydrogen atom can be cancelled. So it makes 1.01 AMU. And also, in my empirical formula, I have one carbon atom. One carbon atom makes 12.01 AMU. Carbon atom can be simplified. It makes 12.01 AMU. If you sum these values, you will obtain the empirical formula mass of the compound, and it equals to 13.02 AMU. Okay. In the question, molecular formula mass is given. I calculated the empirical formula mass. I will put all the facts in my formula. As you see here, n times 13.02 AMU is equal to 78.110 AMU. Then you will divide 78.110 AMU by 13.02 AMU to find n. N is a whole number which is unitless. It's going to be 5.999, and if you run that number, it's going to be 6. N is equal to 6. In the question, empirical formula is given. It is CH. N is 6, we calculated. 6 times subscript of carbon, it is 1. 6 times 1, 6. So C6. And subscript of hydrogen is 1. 6 times subscript of hydrogen makes 6. So it makes H6. So my molecular formula came out, which is C6H6. Here it's very easy. It's really very easy question because my empirical formula is directly given. So by using this empirical formula, I can calculate empirical formula mass. Then I put my empirical formula mass into this formula to get n. Okay, I got N here, it is 6. Then I have second or another formula to find the molecular formula. In the question, as I told you, empirical formula is given. So I multiplied empirical formula by N, which is 6. Then I got my molecular formula, C6H6. But in the second question, things has been changed because there is no empirical formula given in the question, but there are some masses given about the elements. They are called as the mass compositions. So by using these mass compositions, I'm going to first of all calculate or find the empirical formula of the compound. After finding the empirical formula, what we followed in the first in the solution of first question, we will do that in the second part of this solution. So let's read the question carefully. I will explain. I will make everything clearly. I will make everything clear for you. A sample of a compound with a formula mass of 34.00 AMU. Here, as you see, formula mass is given. It is molecular formula mass. Actually, is found to consist of 0.44 grams of hydrogen and 6.92 grams of oxygen. Look, mass compositions of hydrogen and oxygen are given. I'm going to convert them into mole. After converting them into mole, I'm going to write as a subscript for each element to find my empirical formula. After finding the empirical formula, I'm going to calculate the empirical formula mass. After finding the empirical formula mass, I'm going to calculate the N value, and then we will find the N. After finding N, I'm going to multiply it by the empirical formula to get the molecular formula. But it's going to take so long time to solve this kind of questions, but don't worry. If you follow me step by step, everything you will see will be very easy. Okay, let's start with finding empirical formula for our compound. In the question, I have 0.44 grams of hydrogen. I'm going to convert it into mole. It makes 0.44 mole. And I have 6.92 grams of oxygen. I'm going to convert it into mole. It makes 0.433 mole of oxygen. Then I will use each mole of elements as their subscripts. As you see here, hydrogen, its mole is 0.44, its subscript becomes 0.44. And then oxygen is coming, and its mole is 0.433, so its subscript becomes 0.433. And also here I must mention about the order of the elements must be, or order of the elements must be used to find the empirical formula. This depends on the question. In the question, which element is given firstly? Hydrogen. Secondly, oxygen. So my empirical formula must start with hydrogen, ends with must start with hydrogen and end with oxygen. Okay, it's so good. So which one is the smaller subscript? Of course, subscript of oxygen is the smallest one. So I'm going to divide both subscripts by the subscript of oxygen. It makes H1O1. As you know, there is no subscript as 1. We don't show 1 as a subscript. So our empirical formula becomes HO. HO is our empirical formula. As I told you in the solution of first question, we have two mathematical formulas, which are N times empirical formula mass is equal to molecular formula mass, and second one is the N times empirical formula is equal to molecular formula. Here I got the empirical formula, which is HO, and in the question, my molecular formula mass is given 34.03 AMU. I'm going to calculate N, but to calculate N, I need the empirical formula mass. I have empirical formula. Via empirical formula, I can calculate the empirical formula mass. In HO, this is the empirical formula, I have one oxygen atom. It makes 16 AMU. And also one hydrogen atom. One hydrogen atom makes 1.01 AMU. I will sum these average atomic masses of the elements or the atoms. they make 17.01 AMU. This is our empirical formula mass. So I can put this value in my first formula. N times empirical formula mass is equal to molecular formula mass. Molecular formula mass is given in the question, which is 34.00 AMU. And we calculated the empirical formula mass via empirical formula, which is 17.01 AMU. But then you can find N dividing by 34.00 AMU by 17.01 AMU. Then N becomes 2. Okay. And here we calculated the empirical formula. In my second formula, mathematical formula, I will put the empirical formula, which is HO. Empirical formula is HO. N is 2. You will multiply the subscripts of each element by 2. 2 times 1 is equal to 2. It is the subscript of hydrogen. 2 times 1 is equal to 2. This is the subscript of oxygen. Then our molecular formula becomes H2O2. Don't be scared of the long solution, because if you follow the steps, you will see everything is very clear. You just try to understand what are the givens and what is the unknown in the question. After learning or after understanding, seeing the givens and the unknown, you will follow the steps. As you see here, we have very important two mathematical formulas, which are N times empirical formula mass is equal to molecular formula mass. Then here we find the N. Then we use N in the second formula, which is N times empirical formula is equal to molecular formula. Then we find the molecular formula of the compound. Thank you very much for watching me. I'm gonna approach the solution to the camera. Okay, I hope you see clearly. Okay, thanks again. See you.